Hey everyone. So today I'm gonna make a video discussing various things that I know about lysergic acid diethylamide. So I don't have any citations for this. This is just my discussion of it. I'm just doing this because I'm bored. But so lysergic acid diethylamide. It's a drug that's gotten a lot of notoriety. I believe a lot of it is a misrepresentation of the compound itself. But I'll begin with a brief history overview of it. It was first synthesized in 1938 by Albert Hofmann, a Swiss chemist working for Sandoz, which is a pharmaceutical company. So he was actually looking at ergot derivatives to find respiratory stimulants. So what he did was probably just tested a whole bunch of different amides of lysergic acid. And he found this compound LSD, or LSD-25. Now, it was overlooked at first, but then one day, the story goes that Albert Hofmann got maybe a drop of it on his skin, and he experienced some strange effects. And then later, he went and he took 200 micrograms of it, which is a fairly high dose. Not the highest you could go, but it's a fairly high dose. But what he did was he went on a bicycle ride, and essentially that's what Bicycle Day is. When you hear Bicycle Day, it's talking about how Albert Hofmann first realized the power of LSD to unlock the mind. After that, throughout the 50s and part of the late 40s, even into the 60s really, there was a lot of research done on it. LSD was given out for free as delicid, which is basically just an ampule full of LSD and a certain solvent. So it was used for everything from alcoholism to depression to studying how schizophrenia works. It was a real godsend for psychiatrists, actually, because back then psychiatry was not very well developed. It was mostly based on theories of the mind, like Freud. There's classical theories and some behavioral theories. But if you went to a mental hospital, a lot of times your schizophrenia would be blamed on bad parenting or something like that. Now, it was with the discovery of LSD that they realized that psychotomimetic effects arise from ingestion of LSD. So these effects were thought to give insight to psychiatrists into the mind of someone with schizophrenia or any sort of psychotic disorder. It turns out that LSD also opened the gateway to studying serotonin receptors. Serotonin receptors are extremely important. There's a large variety of serotonin receptors, but they modulate a lot of different things in the body and the brain. So research was done. There was some research on psychiatric disorders like alcoholism. There was I don't remember which study it was, but there was a particular study where they gave alcoholics some LSD. I don't remember if it was a single large dose or over a period of time, but I know that there was some reported success. Many of the people who received LSD never were sober from then on. So, LSD, what is it? What's it like chemically? Well, I've drawn up a little picture. Let me see if you can see it. I don't know how well you can see that. It's the one on the left. No, the one on the right for you guys. But basically, you've got this amide moiety. This carboxamide moiety, actually. You've got your indole moiety here. And the interesting thing to realize is that if you look at the structure carefully, you can see that there's a tryptamine-like backbone here, and also phenethylamine-like backbone. if you look at this molecule, which indicates that it's almost like a fusion of the two classes of the two common classes of psychedelics, which are phenethylamines and tryptamines. So, what does this mean? Well, the structure of LSD, it infers that it's going to be a fairly fragile molecule. If you looked at all the stereochemistry, it turns out that only one isomer of LSD is active, and any variety of factors can change the stereochemistry and render LSD inactive. So D-LSD is the only active form of LSD, and there's iso-LSD and all these different types. So, okay, so let's see, let's go into the synthesis. Now this is the part I'm most interested in. My interest lies in the synthetic chemistry of this synthesis, and it's a really, it's kind of overblown how complicated the synthesis is. It's actually more the workup steps and getting the LSD to not degrade that's the problem. So the synthesis starts from the ergot fungus. Ergot is a fungus. It's Claviceps purpurea is the most common one known. It grows on rye. It's a parasitic fungus that grows on rye. Now, what happens is this fungus is pretty much just crushed up, the cells are broken, and ergotamine is extracted. Ergotamine is basically lysergic acid that is bonded to a tripeptide. Therefore, it's very easy to obtain lysergic acid from this tripeptide. So, ergotamine tartrate is your classic source of lysergic acid, but there are many. There's ergocristine, ergoclavine. There's so many different lysergic acid compounds. And it varies from species to species of Claviceps fungi. So, the first step is to hydrolyze the amide from the peptide. The amide bond is easily hydrolyzed using potassium hydroxide, which is a strong base. Usually, I think the solvent is methanol, but from there, lysergic acid is extracted. Now, lysergic acid is it's the one thing that is really the gateway to all of these lysergic compounds that I'm going to discuss. So, So from lysergic acid, there's only one more step, really, is to recouple an amine. In this case, the amine is the secondary amine called diethylamine. So, hence lysergic acid diethylamide. This is the end of part 1. I gotta check the time. I'm about to do something. But I'll upload the next part shortly.